We're going to review a little bit of the graphing of rational functions. The first two, we're not actually asking you to make a graph of it, just find all the details that we need. So, step one is to do what? Factor it all. Yep, factor it all. So what can we factor out of the numerator? If we take an x out, we have x squared minus x minus 6. How does that factor? All right. Looking at the denominator, what can we factor out? If we pull a negative 3 out, what's left? Yes, x squared plus x minus 6. How does that factor? All right, so we have opposite factors. A plus 2 on the top, a minus 2 on the bottom. So will anything drop out? All right, so that's as simplified as we can make it. When we look for points of discontinuity, we are looking for what? What makes the denominator 0? Okay, so looking at the denominator. The negative 3 here, that's a constant. There's no variable there. I can't change it. It's going to be negative 3 forever. All right, but where I have variables, I can look at what makes that 0. So a negative 3 creates a 0 here, and a 2 creates a 0 there. So those are my points of discontinuity. Now I have to decide, are they vertical asymptotes or holes? So if I can get rid of it, I can get rid of the hole. Yes? You can fill up a hole. Can we get rid of either of these factors? They don't have matching ones in the numerator. So these are non-removable points of discontinuity, which means they are vertical asymptotes. Okay? We have no holes. Horizontal asymptotes. What do we look at to figure those out? The highest exponent, what's that called? The degree. We look at the degree. So in this first one, the degree of the numerator is 3. The degree of denominator is 2. What happens when the numerator is bigger? There's none. So I do want you to get in the habit of saying none. Don't just not write anything down or leave it blank. All right, that tells me you didn't know what it should be. If you write none, it tells me you analyzed it, top degree was bigger, so there isn't one. All right, x and y intercepts. How do we find the x-intercepts? Where do we look for x-intercepts? When the numerator equals 0. Okay? What we're really doing is we're putting a 0 in for y, right? But when we cross multiply, 0 times all of this is still 0. So we really just worry about what makes the numerator 0. Looking at it in its factored form, we have a 0 here, a 3 here, and a negative 2 there. So we have 3 different x values that would create zeros in the numerator. Yes? So my x-intercepts. I put a 0 in I get a 0 for x when I put a 0 in for y. I get a 3 for x when I had a 0 in for y, and I get a negative 2 for x when I had a 0 in for y. When we go to find the y-intercept, now we are plugging zeros in for our x's. So if these all become zeros, I end up with 0 divided by 18, which is 0. This point right here, the origin, that's an x-intercept and a y-intercept, right? It's where they cross. So this is my y-intercept as well as my x-intercept. Okay? Second one, how does it factor for the numerator? Okay, x plus 3x minus 2. Denominator, what can we pull out? If we take a negative 4 out of here, we have x squared plus 4x plus 3. So that would factor into x plus 3, x plus 1. Okay. So again, there are 2 points of discontinuity. First one is at -3. Second one is at -1. Can I reduce either of those out of there? So I'm simplifying this expression. X plus 3 divided by x plus 3 gives us a 1, right? So when x is -3, it does what? There's a hole. How do we actually find that hole? We know the x coordinate's -3. Plug it in, but plug it into the reduced simplified version, yes? So our simplified version was x minus 2 divided by -4 times x plus 1. So if I plug that -3 in here, -3 minus 2 is -5. Denominator, put a -3 in here, add 1, it's -2. -2 times -4 is 8. So the coordinates -3, -5/8 would be where the hole is located. When you go to graph that, I need to see a little open circle there. All right, you've identified that that's a hole in the graph. When you look at the pictures on your calculator, you won't see holes. You have to know they're there. Okay. This next one, we're finding the same information, but now we are going to actually graph it. Whoops, I forgot something. What did I forget? X and Y-intercepts. And horizontal asymptote. Wow, I skipped a whole bunch of stuff. All right, let's go back. Horizontal asymptote. What happens when the degrees are the same? Because we have a 2 and a 2. You use the leading coefficients. In this case, the leading coefficients would be 1 divided by -4. So y equals -1/4 would be the horizontal asymptote. For x and y intercepts, x-intercepts, what makes the top 0? 2. Now, notice I used the simplified version to do that, because if I look at the original version, I'd also say that -3 would be an x-intercept, but it's not. We just found that -3 gives us a hole at -5/8. Right? It's not an x-intercept. So make sure you use the simplified version. All right, y-intercept. If I put a 0 in for all of my x's, I end up with -6 divided by -12. So 1/2. All right. Now we can look at this one. Let's get it factored so we can find all those details. We can factor an x out of the numerator. What would be left? X squared minus 9, how does that factor? Yeah. So we are going to have x, an x plus 3, and an x minus 3. Denominator. I could take a 3 out. That leaves me x squared minus 2x minus 3. How does that factor? Okay. Can I simplify anything? What's going to drop out? The x minus 3. So my simplified version would look like this. All right, so points of discontinuity. I have 2 of them. What happens when x is 3 and when x is -1? Let's start with the 3. When x is 3, what happens? That was the one we could reduce out, correct? So that means it is a hole. All right, so let's plug that 3 into our simplified version here. If we put 3's in for all of our x's, we get 3 times 6. So 18 divided by 3 times 4. 18 divided by 12. 3/2, yep. All right. When x is -1, can we get rid of that one? So that is a vertical asymptote. All right. Horizontal asymptotes. We look at degrees. What happens in this one? Top degree is bigger, so there's none. Now, there are other kinds of asymptotes that you will look at as you continue on in math. Okay? For this level, we're just looking at horizontal and vertical asymptotes. But there are asymptotes that look like slanted lines. There are asymptotes that look like parabolas. There are asymptotes that look like a cubic graph. It depends on how much bigger that numerator degree is compared to the denominator degree. So when I look at this, I have a top degree of 3 and bottom is 2. They're just 1 apart. That means my asymptote has degree 1, which would be linear. All right? So this actually has a slant asymptote, not a horizontal or vertical one. You'll see that when we graph it. If the top degree had been 4 and the bottom was 2, now they differ by 2. So now I would have an asymptote that resembles a parabola, degree 2. Okay? So just so you know, there are other asymptotes out there. We're going to focus on the vertical and horizontal ones. You may have a slant one, but I'm not going to ask you to find it. Okay? So this one does have a slant asymptote, but we won't come up with the equation. All right, what do we have left? X and Y-intercepts. So looking at the numerator, what makes it 0? For this first x, 0. So when x is 0, y would be 0. And for this one? -3. All right. Y-intercept. If I put a 0 in for x, what do I get? We already found it, didn't we? Yes? If I put a 0 in for x, I got 0 for y. Remember, if it's the origin, it's going to count as both an x-intercept and a y-intercept. All right, let's take a minute and list all of this information on our graph. So we said we have a vertical asymptote at -1. We don't have a horizontal one. We have x-intercepts at the origin and at -3. And we said we have a hole at 3, 1.5. Remember I said that you have to have a couple points plotted in every chunk of our graph? Well, our graph is basically divided into 2 parts, right? Either side of that vertical asymptote. I already have 2 dots to the right of my vertical asymptote. I want to get at least 1 more dot on the left side. So let's look at what happens when x is -2. So go back to our simplified version here. Let's put that -2 in. We get -2 times -2 plus 3 over 3 times -2 plus 1. So we have -2 times 1. And we have 3 times -1. So 2/3. All right, now our vertical asymptote is a line that our graph should be approaching. Yes? So what our graph's going to look like, we have a branch coming up here, approaching that vertical asymptote. We have another branch that's coming up along the vertical asymptote, crossing at the origin, hitting that hole skipping over it and continuing on past it. Okay? If you're going to check this on your graphing calculator, remember that you have to put parentheses around the whole numerator and the whole denominator. Okay? Can you visualize a slanted line going through here that your graph's approaching? Okay? So that's what I was referring to when I said a slant asymptote. It's going to approach it down here. It's going to approach it up here. Okay? All right. Turn to the third page where it says mixture problems. Yesterday we talked about a mixture problem, something about saline solution. We were trying to dilute it. Okay? Mixture problems are all set up in a similar format. It's just which piece of information you're missing that we can change up. Okay? So, to find a concentration, we need the total of that substance. All right? In this case, we're talking about a sugar solution. So we need the total amount of sugar compared to the total volume. Okay? Yesterday it was a saline solution, so we needed the total amount of saline compared to the total volume. This one says a sugar solution was made by mixing 7 milliliters of a 50% sugar solution with 3 milliliters of an 80% solution. Find the concentration of the new mixture. All right, so let's fill in what we know. How much total volume do we have? We had 7 milliliters of the one and 3 milliliters of the other, yes? So denominator is the 7 plus 3. Okay, total volume. The numerator is how much of that total volume is actually sugar. So if they tell me I have a 50% solution, it means half of it's sugar, half of it's water. So of my 7 milliliters, half of it is sugar, 50%. Of my 3 milliliters, 80% is sugar. So I should be able to figure out total amount of sugar divided by total volume. What's half of 7? 3.5. What's 3 times 8/10? Don't grab your calculator. 3 times 8. All right. So 3.5 plus 2.4 gives us 5.9 divided by 10, which is 59 hundredths, which would be what percent? All right. So our new mixture is a 59% sugar. Question 2. How many gallons of a 65% saline solution must be mixed with 8 gallons of pure water to make a 25% solution? Okay, so just like our sugar one, this time we're dealing with saline. So total amount of saline. How many gallons? We don't know how many gallons, but we know its concentration is 65% saline. So 65% of that liquid is going to be saline. What am I mixing it with? Pure water. How much water? 8 gallons. What is the concentration of saline in pure water? Does pure water have any saline? No. So 0%. Total volume. How much did we put in there? X plus 8. We added X milliliters to the 8 that we already had. This time, though, we know what we want for a final concentration. 25% would be what decimal? Yes. All right. How do we solve that? Cross multiply. All right. Let's multiply our x plus 8 over to the right-hand side. So we have 65 hundredths times x plus 8 times 0. 8 times 0 is? Come on, guys. 8 times 0. 0. All right. Multiplying x plus 8 to the 25 hundredths. We end up, when we distribute, 25 hundredths times x plus, what's 25 hundredths of 8, or a quarter of 8? 2? All right. Moving our x's to the other side, we have 4/10 left. 4/10 x equals 2. 2 divided by 4/10. What? It is 5, right? 2 divided by 4/10 is the same as 2 times 10/4. 20 divided by 4 is 5. So we need 5 gallons of the 65% solution to get the right concentration. All right. Skip to question 4. It says Kristen wants to make 6 gallons of a 34% alcohol solution by mixing together a 24% alcohol solution and a 64% alcohol solution. How much of each solution must she use? How is this different? We don't know how much of either of these solutions, right? But we do know a total. How much total volume do we want? Okay, so let's say I add 1 gallon of the first one, I would need 5 of the other one. If I have 2 gallons of the first one, I would need 4 gallons of the other one, right? Has to add up to 6. So we have 2 different concentrations. We have a 24% and we have a 64%. If I say I'm going to have X gallons of the first one, how can I express the second one in terms of X? What did you just do? When I said I had 1 gallon, you told me I would need 5 of the other. When I had 2 gallons of the first, I needed 4 of the other. What are you doing? If I need X gallons of the first one, I would have 6 minus X of the other one. Yes? So once I know 1, I can figure out the remaining one. All right, let's set it up. We want X gallons of the 24%. We want 6 minus X gallons of the 64%. Our total volume is 6 gallons. And we want a concentration of, all right, 34%. All right, let's distribute. What is 64% of 6? Grab your calculator. 64% of 6. Okay, thank you. Minus 64% of X equals, can we multiply the 6 to that side? Thank you. All right, combining like terms. If we put our X's together, we're at negative 4/10. What happens when we have 2.04 divided, or sorry, minus 3.84? Okay. Now divide by the negative 4/10, and we get what? For this one, we are having to find 2 answers. X we had as our 24% solution. So we would say we need 4.5 gallons of the 24% solution, and how much of the other? 6 minus 4.5 is 1.5. So 1.5 gallons of the 64% solution. Mixing those two together will give us 6 gallons that is 34%. Okay? So can you see how we can take out different pieces, but they're all kind of set up the same way? All right, so your homework for today, there are several little parts to it. You have 2 graphs in the packet that we were just doing that we skipped over, yes? I want you to do those 2 graphs. I'm going to pass out a blue worksheet. That worksheet has excuse me, some mixture problems and some work problems. Do you guys remember when we did the work problems? Like there's 2 people painting a house. How long does it take them to paint it together? Those types? Okay. So the blue worksheet. Then in Schoology, there is a code for your hour. There's a 5th hour code for a quizzes. Okay. The quizzes has to be done when you come in on Tuesday. Okay? So if you have too much to do tonight and can't get that done tonight, then you need to do it over the long weekend. All right? But it has to get done by Tuesday. Tuesday, some band kids are gone. I heard there's a field trip. So tomorrow, make sure you grab the worksheet that you'll miss on Tuesday because our test is Thursday. All right?